Okay, so first of all, thank you everybody for being here in person and on Zoom. Today we had our first industry talk of the year with Civil Project, which is a specialty engineering consulting firm.
That's correct, yeah. We're structural civil engineers who do building diagnostics and engineering design and construction diagnostic works in both building and civil type industries.
So today we're lucky enough to be joined by Denise, who is the
Principal
principal
engineer.
engineer, and
Matthew is our national technical manager. Yeah.
Okay. So if you guys want to start with the presentation.
Yes, certainly.
Build up.
Yeah, so Civil Projects is a consulting engineering firm as described, and in saying that, we're both graduates of Sydney University. Just to let you know that I graduated in 1999. Matthew, 2013. 2013. So we've been a part of Sydney Uni, love Sydney Uni where we went, and seen a lot of change. Obviously, when we walk through here, there's been a lot of changes with respect to the buildings, except the actual civil engineering building. But in saying that, everything has evolved as has engineering. So being a civil engineer, completing Sydney University, we've moved through and have gone through and done a number of different jobs and experiences. Thank you. And for the past 25 odd professional years, we've moved through the industry, and I'll give you a bit of an explanation of my background professionally, and then how that's evolved into Silver Wolf Projects and what we do as an organisation today. So we'll move to the next slide. I should have the control. So in essence, what we do, so Silver Wolf Projects, as I said, is a civil engineering construction based consulting industry, and we work in the insurance field. And when I say the insurance field, that's assessment of insurance claims in buildings and in structures. So most buildings, majority of residential and commercial buildings are insured. And what we do as a company is we receive instructions from insurance companies or loss adjusters or other agents of insurers to provide building diagnostic reports, scopes of work in reinstating damage as a result of insurance events. Now, what's an insurance event? An insurance events could be the storms that we've received, hail, wind, car impact, flooding, burst water pipes, building movement as a result of ground movement, earthquakes. All these natural disasters that we receive, buildings suffer damage from that. And our company goes ahead, does the inspections of those buildings, provides building diagnostic reports on the basis of Australian standards, design principles, building principles, and then recommendations for repair, or otherwise reasons or causation of why that's occurred. So in the past 15 years as operating Silver Wolf Projects, we've looked at many natural disasters, from earthquakes to cyclones, to general fires, to flooding events recently. So that's what our background is. And as engineers, we're placed with the responsibility of giving technical reporting, which is non-biased, based on our information in the sense of our knowledge that we've learned as engineers structurally, and then reverting back to the Australian standards and codes that as students you learn and go through in the formal technical way. So that's a bit of a listing of what we have covered as a company with respect to these natural disasters that have occurred, and these have been beneficial for our company's growth over the years. In saying that, my just a bit of a breakdown of me. As I said, I graduated in 1999 from Sydney University with a Bachelor of Engineering with honours. After doing that, I went to work as an engineer, and I'll go through, we can basically got a job as on the construction side of engineering. And in doing so, then went to TAFE for 2 years and did a building course. That was more of a background understanding of building mechanics with respect to rounding yourself as an engineer. So when you're at university, you learn a lot about the academic side of university, the studying of the structures, the calculations as you've done. You do the steel, you do the concrete designs, you work about the geotechnical side of things. But in saying that, as a professional, you will then move forward postgraduate. Either you'll do a master's or you go and do other courses such as the building course. And in professional manners, you may do a demolition course or you may do another business course, and that rounds you as a professional. And as a result of that, you can then get licensed, and to operate in states, you need to be licensed as an engineer if you're practicing or providing advice structurally. And in doing so, you need those qualifications. Just a bit of a rundown. We'll go through this very quickly. Just my CV. When I first started as a graduate engineer, it was a little bit tough actually to get work at that time. It was just coming out into the Sydney Olympics. So that was in year 2000. There was a big boom in construction. And after that construction boom, there was a lull. At the time that you guys are going to come out, you're in a peak of construction. There's a lot of new work. And that's why you're going to have a lot of opportunity with respect to employers and your ability to do what you want. But at that time, it was tight. And as a graduate engineer, you just basically put out lots of letters those days. There was no SEEK. It used to be in a My Career paper. And you'd send all these letters and you get these Dear John letters back saying, Dear John, as we used to call it, thank you very much for your application. Sorry, you're not going to get that. And they were very kind, actually. You actually used to get a response. And we'll talk about applications in the Q&A section. So as an engineer, you're a graduate. You don't really know a lot. You know what you've been taught. But when you get out into the workforce, you get the opportunity to work wherever you're placed. And if you're lucky, you can go where you want. But in most cases, you just get a job. And you start in that field. And most engineers in their profession get pushed into either consulting, and if you're lucky, if you wish to be a design engineer, or they move into the construction or the construction management side of things. In doing so, when I first started, it was in the construction management, but I always had a burning desire to be a consultant, which was very difficult to move out. We can talk about this in the QA section of where you want to go. But if you want to be that and you've got a desire and you don't get that your first job, it's not the end of the world. It means you take on the information that you get at that time and you then position yourself and learn to move into the career that you wish. That may be hydraulics, it may be geotechnical, it may be structural, it may be civil. As a civil engineer, which is the term of what our degree is, all those elements of those subspecialties derive from that. So we'll move forward with the next slide. We'll keep going. These are the other companies. This was an interesting one. So again, moving from one side of the original job that I had, just so you give an idea of where you as an engineer go from one position to another. Started off as a civil engineer on site constructing roads. A lot of the freeways that you probably drive on, I was involved in building, or in part of the teams in building those. That was the M5 West and the M2 extensions. In saying that, we moved into a different field in demolition of high-rise buildings, which was very interesting, where I worked as a project manager and coordinating and understanding the way how the building would have to be decommissioned or demolished, which is a reverse of construction. It's a reverse of understanding the design principles, which again gives you good roundedness. And in essence, we fell into this insurance game, which for 15 years now we've been involved in. And this job, in which we'll explain what Silver Wolf does and the beauty of this particular industry that we're in, gives you the variety of work. We're constantly having the variety of different perils that cause loss to buildings or structures. They're different elements that cause distress or force or collapse or movement. And we as engineers, as professionals who understand how buildings work and the mechanisms of those buildings, are able to then diagnose those and provide reports, then in turn designs and scopes of work and reinstating those back to pre-loss. So that's what Silver Wolf Projects does at the moment. And Silver Wolf Projects, as I said, was established in 2007, and we've currently have over 35 odd engineers, 25 odd engineers in New South Wales. We have 3 in Victoria, 1 in the ACT. We have 3 in Brisbane and 2 in South Australia. And we have now a new wolf, we call them, a new engineer in Western Australia. So it's a very exciting business. And with insurance, it's a national business. There's work constantly coming on from the weather as we're experiencing. And in doing so, I'll explain a little bit further on what we do. So if we could just get to the next slide. keep going to the next slide. We'll move forward. Keep going. That's what we're doing now. So as I said, Silver Wolf Projects is a bit of a list on what we do. What we call it in the terms of our work is forensic engineering. So forensic being the reverse engineering from predetermined original engineering, in the sense of building something from scratch. So when you design something from scratch, you start from top down, that being you work your loads, you work what the material is going to be, you work the capacity of those materials, and then you work the structure. In forensic, it's the other way. You're working out why the particular structure has failed. And then from there, you work why the material has failed. Then you can look at the loads and look at some defects or why or how that hasn't been constructed or designed correctly. So it is a skill set. It's interesting because it's reverse, but in saying that, you need to know the front end as well. And we do that. The gift of what we have is that we not only just do the forensic or the reverse, we have to then reinstate it because someone's property or house or structure has been damaged. We need to then provide that back to a pre-loss condition. So in saying that, we do other things as well. So we do other formwork or temporary works, again, which is development of schemes or systems to temporarily prop or support structures that are in process of being built or are in process or have been forced or damaged that are unstable. And in doing that, we then create systems by engineering principles and design and calculation to support that structure to make it safe. So again, that's very, very interesting type work. It's also very responsible. So as engineers, the buck stops with us with respect to a structure and its safety. When someone asks, when there's a building in distress or there's a building that is unsafe, they ask the engineer is called on site. The engineer needs to make that decision. He or she needs to make a clear, precise outcome to provide the quality and the quantity of information that can leave the people satisfied that it's safe, and we hold that responsibility. And unfortunately or fortunately, that's the role that we take with very little credit. But as engineers, we do that because that's what we do and that's what we've been trained to do. So it's a very highly regarded profession in the sense of what's required for people's safety and public safety moving forward. As I said, we do other types of engineering type works revolving around civil design, hydraulics. Again, and what you learn and what we do, and after you leave, you just keep gaining knowledge and skill sets. And that's the beauty. You get taught how to do something here because engineers make it happen. And that's what engineers do. We're gifted to solve problems. Problem solving is not only just about calculation, it's about solving a problem. And that's why they come to an engineer to solve that problem. And that's why you're here. That's why you're gifted to do that. They don't go to a lawyer to solve a problem. They come to the engineer to solve a problem. They don't go to the architect to solve a problem. They go to the engineer. Although the architect makes the building pretty, we make it stand up. We're the ones in the end that make that happen. So we'll go to the next slide there. And I'll just quickly go through so we can get some questions. I suppose we've been talking. But as I said, we provide those building diagnostics and inspection reporting services, which requires written skill. It requires numeric calculation and calculating what's wrong through the codes and through the standards. We also use software to provide advice on damaged members or elements of buildings to replace. We keep going from there. So these are some, I've had to put some photos here. I mean, this is an example of what we worked on in the residential commercial, but this is a civil photo. So I don't know if you can recognise this photo, but we were involved in this. This is the Sydney Light Rail on George Street. So we were involved. Acciona were the head project, were the head contractors. They're obviously international. We were, and that type of job it involves many consultants, many contractors, many players. And our little part in this project was all the lighting poles that were on that project all needed to be installed and designed for the light rail to hold the trams. Now, given that they have a generic design, and the generic design was quite simple, so it's a laterally loaded pile. There's a wind load. You learn this sort of stuff. From memory, we did it in soil mechanics mechanics one, there was a book. Anyway, you learn about the laterally loaded pile. But when you get on site, you can imagine on George Street, you can't just go and drill a pile 2.5 meters deep. You've got services, you've got other assets in the way. Everyone was scratching their head. They didn't know what to do. On that site, you've got designers who designed it many years ago. Then you've got the engineers who are on the site, the construction engineers, project engineers. They need answers. They're needing answers because there's machines waiting there. They need programs to fix. They're under pressure.
I think you
But they
need
come
here.
to
I
us
need here.
as engineers, as temporary works engineers in this particular engagement, to come up with ways of how we're going
I
to
think you need
manipulate the design and come up with new designs to put that pole in that location, but put it over there because I can't put it here because there's services in the way. So we had to come up with cantilevered poles, had footings, poles that look like something out of a movie. It was all these different designs. And the whole point of that was to constantly think and solve problems. And these pole designs, without going into the technicalities, obviously were calculated to resist the lateral overturning from the wind load of the poles themselves. But that's an example of temporary works. In saying that there were excavations done there, we did the shoring works on that. So when they were digging the services, you can see the service trenches there. Those needed to be supported. Anything over 1.5 meters by code compliance says it must have shoring or some sort of engineered system. Those systems have surcharge loads that need to be accommodated because you're not only supporting the ground, that being the soil, but we're supporting also the surcharge applied by the machinery. So again, need to come up with the design, but they need special materials. They've only got timber. They haven't got anything else. So we've only got a bit of plywood and a 4x3 or whatever material they had. We had to then accommodate that. So it's constantly thinking and moving and resolving problems. So that was an example there. Again, you've got your traditional type design work, which we do. And as a traditional consulting engineer, which many consultants do, and as you're designing, is concrete structures. In this particular case, this is a slab on ground in a commercial application. It's much simpler design in the sense that it's not suspended and without all the complications of that. But again, we still need to take into consideration loads, the application, thickness of that concrete, understand the conditions of shrinkage, understand what the usage is and abrasive measures, and there's standards and codes for that. And we again look at that type of thing, but also in sense we would do building diagnostic work on that. So when concrete cracks, people may put a claim and say why that cracking has occurred, and you need to understand the principles of building material science and understand what you learned in materials. I think you would have done in year 2. I think it's year 2 from memory, but anyway, maybe who knows what's changed. But you'll understand why concrete cracks, why reinforcements in that concrete, and what stops shrinkage, which I don't know if anyone can answer that at this moment, but the shrinkage and the cracking, why we need articulation, why we need construction joints, and that's another reason why. So when you design something, you understand why you put it in. When you do the forensic backwards, you understand why it's cracked. So you get a dual understanding. So when you become a designer, you say, oh yeah, I know that. That's why that cracked. I'm going to put that construction joint in. So you get this benefit of both worlds, where if you only work on one side in designing, you don't really see the end product. Exactly. You don't see what's gone wrong in order for you to implement it in your front end design. So that's an example of some design work there. And again, retaining walls, you'll do many retaining walls. Retaining walls are a very common structure. Probably done some retaining walls possibly in the geotechnical side of your studies, but there are many retaining walls and many failures for that. You'll learn about the failures of sliding, bearing, overturning. These are elements that you'll learn with the Australian standards that are relative to that, and you'll learn about gravity systems, cantilevered systems, board piled systems, reinforced concrete, block work, all these types of elements. And as engineers, you'll design those. But as a forensic, you'll need to understand why that retaining wall has failed. Why did it fail after heavy rain? Was there enough drainage to mitigate the hydrostatic pressure buildup? Was there enough drainage provision? Was the footing deep enough? What was the soil that was built on? Did it fail because of sliding? Did it fail because of bearing? These are the things you need to understand. So you'll learn all these elements. You'll learn all this in your courses, but when you get out into the professional world, it all comes alive. And as an engineer, there is nothing more stimulating then having that knowledge and the ability to provide that information to your clients and to people that are requesting that those directions. So that's the next slide there. Again, this is pretty much what we've spoken about, or what we do as the forensic division of our business. So we'll go back to Silver Wolf Projects as a company, and that's why we're talking here, given the opportunity to be here, and we'll disclose further once we get into the question and answers. But in saying that, we're a company that is, as I said, 16 years old in May, full engineers, run by engineers, have an idea of what's going on, and we're starting to build our wolf pack, as we call it, because we're all wolves in our company, to build a professional outfit that stimulates not only our engineers, but graduates and interns. So it will be something that we're looking to embrace, especially Sydney University, given that my personal feeling for Sydney University being, alumni here, to be a part of what we do and that learning path. So we'll go to the next one. That's just a bit of what we said. That's so again, there were some of the exotic type losses. So when someone's driven through a car's driven through the building, that's a very basic case. But in this case here, the elderly person thought the accelerator was the brake, and it's a very common thing. They went straight through. Now, the issue now is that building is being supported by that car. So there's two things that need to happen here that we were requested to do. Firstly, everyone's going, oh my God, is she all right? They got her out. But in order to support this particular building, they need advice. They've got to pull the car out. Now, if I pull the car out, what's going to happen? The building is going to collapse or implode in some section. So they need advice about propping. And this is a very simple case because it's a single story brick veneer. Now, in saying that, it's still supported by the internal timber frame and the roof framework that the roof's holding. So if I pull that out, that section of roof that will implode. So we need to give the advice of basic example, but give the advice of what's required. So the fire investigation or the SCS can pull the car out. Car can be removed. They make it safe and prop it. And then a scope of work to reinstate that building needs to be put together, which is what we would do in order for that to be reinstated back to a pre-loss condition. So those people can go back in their house or can go on. So that's just a very simple example there. This one's an example of where it goes wrong as well. So again, forensically, we come on a site. The entire roof has collapsed. It's collapsed. It's imploded. Now, it's imploded for a number of reasons. It's imploded because there's elements of that timber roof structure. Now, I'm going to come back with timber. I don't know whether Sydney University, I didn't do it at Sydney University at the time. Timber wasn't a design element. It wasn't a design subject. You learn that more whilst you're on the site. I know other universities may do it, but there was an element here that was missing called an underpurlin, a collar tie. And that collar tie holds the rafters together. And those rafters are held by the ridge. And whoever built this, they wanted to have this sort of cathedral look, which was great. So it just had this lovely look with the rafters and nothing holding in, because that basically holds the spread. What they didn't realize is when they put the tiles on there, obviously you've got the dead load now of those tiles, and that spread occurred and it's collapsed. Now, it was all a big pile here. But from an insurance perspective, they put a claim in. Now, we've been asked by the insurance company to provide a causation report on why this has failed. Now, when we come to it, it's failed because of defective work. And that's something the insurance company needs to understand in order for them to either respond or decline to their policy. We don't talk about that. We just provide the facts and we provide what's going on. So again, you provide a technical report. We refer to reference standards for timber structure. So in this case, this would be 1684, residential timber frame construction. And that would be provided a professional report and given back there. So that's another example. And as I said, we did demolition stuff, and with demolition project planning and management, demolition is a dangerous process because you're deconstructing a building and you just cannot do it in a certain way or you kill people in doing so. So engineers are involved in providing advice on how to demolish or deconstruct a building so it can be demolished safely. And we provide that advice. And again, it's a reverse of construction. With construction, you start from the foundation up. With demolition, you start from the top down and understand that. But in doing so, with a high-rise demolition, with high-rise buildings being demolished, the machinery that's needed to demolish those buildings needs to be supported on the slabs that this is being demolished. It's a process that goes down. You don't understand, when you build a building, when you design a building, you don't design it to be demolished. You design it to be used. So designers don't allow for the live loading that's going to be required by the machineries on the slab here. So we're standing on a slab here. This is an auditorium. I think from memory, it's about 5 kPa. 5 kPa from 1170.1, which is what you will learn, which is the standard for loading. And it tells you that an auditorium area, 5 kPa, that's it. But a machine's not going to impose 5 kPa. So we need to backprop that. We need to backprop depending on the machine they want to use in demolishing that, and then work from there. So again, it's very interesting. It's another method of engineering. And again, as I said, emergency type inspections as we've done. So as an engineer, you're not restricted to a certain area. You're actually able to do everything and anything anywhere, because the skill set is required everywhere. That may be New South Wales, Queensland, in regional areas, in areas outside of, you will never go to. So it gives you an experience, and Matthew can explain this in the QA as well, that you'll go to areas that you'll never have gone to or seen, or structures or met people that you would meet in normal circumstances. And it's a lovely opportunity to see the country, because depending if you're office bound, that's another story. But if you're office bound, you still have the ability. But if you're on site and you're doing inspections, which is what we do, you're moving from different places, you get to see different structures, the way they're built, the way they're designed, how they should be designed, how you shouldn't design it, and you learn all these different skills. So in doing that, we use other technologies as well. So again, when we do our inspections as engineers of forensics, but even as doing design work, yes, we still use first principle calculations. Yes, you still have to use all those codes. But in saying that, when a professional point of view, there are softwares now that have implemented those codes into a manageable system that's commercially viable. You can't do design work from first principles anymore, which you're probably doing from, third year, you started doing steel structures or concrete structures, and using 4100, for example, using first principles on working out, a size of a beam. There's better methods, there's easier methods, and there's tables and there's softwares you can use, subject to obviously working out the loads. Loads still need to be calculated, and you still have to understand what you're doing. But in saying that, there's technology in doing that. We've also used other technologies such as thermal cameras, lasers. I understand we're talking with one of the guys here about the surveying. You still use that type of, you're still going to use it in certain extents. So we use that type of information and technology, plus other software as well. And we validate failures and provide advice. Now, again, this is just another example. You see plenty of these shop awnings. Again, a very basic structure, but unfortunately one that fails. And the reason why it fails could be for many reasons. But they failed in this case because the awning ties. This is a cantilevered. It's a tied structure which is supported by a diagonal tie, and the horizontal member or the support beam is supported by. So it's not cantilevered. It's supported. It's equally supported. And when that support fails, being at the end of that diagonal tie because of rust or corrosion, then it becomes a cantilevered structure. Then it fails because it wasn't designed as a cantilevered structure. It's actually designed as a simple supported structure at two ends. So this is an example of that. And again, we need to write a report on why this has occurred, the reason why it's failed, causation. But in saying that, it's not only just one point of failure, it's a second point, which you can see where the brickwork parapet is, it's pulled out that tie. And now that tie there is tied back to the building in order to resist the load from the diagonal tie. So there's a transfer of loads that you need to understand. And again, very simple engineering, simple reasoning, but those first principles are what's required. And then we would have to redesign that awning, and that requires design, steel design, to provide that information back. That's pretty much the next slide. And this is, again, we'll just go back. This is the last slides here. Again, with technologies, we again implement technology to identify pre-existing structures. In this case here, this is called a pile integrity test. This pile integrity test is a echosonic test, and it's technology that we would use that identifies a depth of an existing pile structure. Why are we doing this? Well, there are structures out there that we may be able to implement and use, but without being Superman, you won't know what the depth of that is or whether it's structurally adequate or can be used in another structure. So in this case, again, this is back on the light rail system where in the city there were existing piles. If you can remember, there was a monorail system that they removed, and there were those piles that were there that were used or wanting to be used. There were great structures that they wanted to tie in or use to implement their new structures, but they couldn't validate what the depth of those were, so they couldn't validate what the structural integrity or capacity was. So this machine here, again, technology, works on an echosonic, where you bounce an echosonic, the echosonic itself goes down to the bottom of the pile and comes back to a reader and identifies the depth of that pile and if there's any fault, as any breakages or cracking within the pile. So that's something that we use, and then we're able then to identify, okay, that pile is 5 meters deep, it was 900 diameter, therefore the capacity of that subject to the soil being, say, 150 kPa lateral capacity in there and some shear in there possibly, and then we can work out what the capacity is and then see whether what they're proposing would work. So that's an example. And then we've got another example of another small tool where we would test, which we do. This is called a pull-out machine, where we test existing bolts or newly installed bolts for tensile capacity. That's the pull-out capacity. So when you design a mechanical fixing in a masonry wall, which is a very simple design, but very important because elements are fixed to buildings, and if those bolts, in some cases which are integral to holding those elements together, fail because they haven't been installed correctly, although the design may be sufficient but haven't been installed correctly, we're there to test that and certify that. So again, these are very simple measures, but these are hands-on practical elements of what we do too. So that's who we are. As I said, it's a dynamic type business in the sense it does lots of different things. It just doesn't do designing of high-rise building or designing of standard. We do everything, and it's quite varied in that sense. And in doing that, it gives a good understanding of structures and engineering and keeps it interesting there. So I think that's pretty much a rundown of what we do. And I understand there's going to be some questions.
Yeah, so if anybody on the Zoom wants to put questions into the Slido, or anyone in person has any questions, otherwise we do have some pre-planned questions. Any live on the floor yet? Or okay, so we'll just start on this. So what drew you to engineering consulting, first of all, over the other streams? I know you touched on earlier how swapping between, and I'm not too sure your journey into it either.
I'll give it to Matthew to answer that one. I'll give him an opportunity to give his view already explained out.
Yeah, so as Dennis already said, that generally when you first get into the field of engineering, you go out, you get your work experience, and you're generally pushed into one area of the engineering field or civil engineering field. My first job or my undergrad experience was in consulting, and I did 1 year at a consulting firm there, and then I went off and I designed to another firm, and I did 2.5 years of designing basically medium high-rise buildings, industrial structures. Anyway, that gets quite repetitive. You're just using 3600, you're using the same design software over and over again. You're designing footings, you're designing slabs, you're designing steel structures. It does get repetitive. I was looking for a change as well, because you do get to a certain point where you start to get a bit stagnant. Anyway, this is when I found the world of forensic. It's not really something that when I was at uni was really talked about much, or not many people did it. It wasn't really, everyone wanted to sort of go to either construction or into consulting. So whilst I still do consulting work, we still do design work, it's much, much more diverse compared to going to a consulting firm where you're only doing steel structures, high-rise buildings, and those style of structures. So when I got this job, which I think I've been with Silver for 6 years now, like the diversity, no day's the same. You're meeting so many different people. You're traveling around, as Dennis already said, to different parts of New South Wales, different states. I mean, I'm regularly, and Dennis is regularly in Queensland, Victoria, South Australia, and all around New South Wales as well, visiting regional areas. I spent 2 weeks down in New South Wales after the bushfires, and obviously a lot of redesign in that, redesign properties and consulting work down there as well. So, and the diversity is really what I love about this job and this style of engineering.
Well, I was next going to ask you about the diversity of the company and how it's allowed you to diversify your experience, obviously working Sydney versus Coonabarabran, or like even just commercial versus residential. So obviously this has allowed you to have diverse experiences in that. Also, I'm sure something that everyone will be very curious about is how, or if interns and recent graduates can be involved in your company, or if they've liked what they've heard and everything, how they can get involved potentially.
Look, exactly right. We're very open to those that wish to be a part of what we're presenting here as an intern, to get experience in that respect. We have already gone through the journey of an intern, not from Sydney Uni, from UTS, who knocked on the door and said, I'm here. She's come on board and now she's working 2 days a week with us. And she's picked it up and she's loving it. And that's what's given us the idea to come back. And it's given me the idea to come back to where I came from, to provide that same opportunity. And that opportunity is something that you can learn and gain from if you want to be a part of this and this is where you want to go. And in saying that, people do courses and they finish and they just do what they're going to do. But if you want to get into this and you feel this is where you're going, then there's an opportunity, as you said, for the intern to apply, or interns, and come and have a chat and let's do what we can do. It's a journey that will take you to many places, and it's a start. And the thing in life is, and I don't want to be philosophical, but it's not where you start or what you feel good about. It's what you don't. You may come and say, well, you know what, I don't like it, but that you learn something from that. Or you may say, well, I like that. I didn't like that, so I want to do that. So it may give you the direction of where you want to go. But yes, to answer your question, yes, interns, well, the applications of interns, we're not just opening the door and everywhere, but the interns, you apply it through our website. So on our website, we have a career section and there's an application process there. I think we've got the link as well. But yes, certainly open and let the journey begin.
Yeah, and we will be sharing the link with everyone who checks out the Facebook event for this, and it'll be made available to everyone. Also, what are your favorite things about Silverwolf as a company, and what do you think it has offered you that potentially other companies you've worked in haven't allowed you to do, or just your favorite things about the company overall?
As we previously mentioned, the diversity of the work, right? So when I was working in these other companies, using the same standards every day, 3600, 4100, the 1170 loading codes. But when you look at our library, there's hundreds and hundreds of standards in there. And you have to have a good understanding of these standards in the diagnosis. So my knowledge has been so broadened by doing this diversity of work and having the time and putting the effort into reading the standards, getting the understanding and applying these as well. So rather than you just going to do design, you actually are applying this in everyday situations in the forensic field. So that's one thing I definitely love, is the fact is that you are literally doing research all the time to work to basically calculate and diagnose the cause of a failure or cause of damage to a building or a structure, any type of structure. So that's probably the one thing that I absolutely love, and the one thing that really has attracted me and keeps me in this field.
Obviously, Silverwolf Projects has a pretty niche area in the market with the forensic engineering. How do you see the company as a whole growing and changing in the future, maybe when everyone here has graduated and into the workforce, or even just in terms of location where people can work or what type of work people will be able to do, that sort of stuff? Where do you think the company is heading?
As I said, the company's stream of income in the sense of their clients is the insurance field, and insurance is something that all buildings, majority of buildings, hold. So as population grows, people need to live and work or to be holding these properties. So the amount of properties or building and structures will increase, as will infrastructure. And these need to be assessed, as well as the older buildings that we are currently living in age. All structures, as people do, age. They deteriorate and they need maintenance. And forensics, in our view, is for insurance purposes, but you've got also forensics in general building maintenance or upgrade or capital work. So all these buildings at one point, everything that you're seeing here, not the Zoom, but obviously everyone in the room here, these high-rise buildings or standard buildings are deteriorating and will need to be assessed by an engineer. They will then need to be recognised and what's wrong with them and what needs to be fixed. So the market will just continue. And unfortunately, we have a decrepit age of buildings, not because they're old, but because they're being poorly built. And you may be aware of all this from the media and other issues that will need rectification, will need strengthening, will need to be looked at by engineers and to provide that advice and specification to keep them safe. So to answer your question, it's a growing industry. It will continue to grow. And in terms of what we do, we've got that element, but we also have the weather that, given the type of weather we're having and the weather patterns and the change, we're constantly having issues with the weather and what that does to buildings and structures. So it's definitely an industry that isn't on the decline. It's on the industry on the incline, and it will only produce further work and opportunities for those that are a part of it.
So what would an average day for either one of you entail? Is that more on site or research, or, you know, do you get to change things up a little bit and do a bit of everything?
So we have a few different roles in our company. We have basically our desktop engineers and designers that will stay in the office, and they're quite happy just basically doing design, reporting and diagnosis. Then we have our field engineers who will do a bit of both as well. So someone like myself, who, whilst I'm also managing staff and looking after the technical aspect, I will go out and undertake inspections. It may be a whole day, it may be flying away for 2 days, or it may be 1 or 2 in the morning. Then I come back to the office, I'll then basically upload everything I've done, and then I'll go through that. Either I'll write the report myself, or I'll pass that report on to one of our desktop engineers. And basically they'll take it from there. So we also have, like I said, we also have specialty design engineers, so people that will just do design stuff, and they will also do their own drafting as well. So we do have a diverse range of people, and that's basically, Dennis is, he'll also do meetings with clients and obviously business development as well, which is another part of his role. So, but my role will typically be 1 day a week, I'd be out on site and doing inspections, whilst one of our site engineers, who just also does both, they may be out for 3 or 4 days at some stages, depending on what their work schedule is like. So yeah, and then whilst you're out, you get to see different parts of the country as well. So that's basically a typical day.
Just as a final bit of advice, I guess, what would you be looking for in new graduates, and what do you think is most important skills to develop or approaches to take when graduates are looking for jobs?
It's a great question, and it's one of the skill sets that, if I give you my advice, you'll always get a job. And always do 2 things. Always look presentable, look the part, look with the assertion that you're an engineer, look the part in being professional, And when you come and present that way, you will project that energy that someone wants to be a part of. So always be at the best presentation. It sounds a bit formal, but always be punctual, be presentable. And secondly, you're offering your services to someone who's employing you is a transaction. And a lot of graduates, and even not even graduates, anyone in the employment field, when you demand, I want experience and I want this and I want that, you're not going to be favorably looked at. When you say, I can give you this, so it's a sales, I can offer you this. As a graduate, I can offer you my ability to assist you or my ability to learn and be a part of the company. Giving to that stage is going to be opening up your opportunities rather than saying, and even in your covering letter saying, I'm a graduate and I want to have experience in this and I want this and I want, reverse it and say, what I can offer you as a graduate, I have the ability to give you this output, or I have the ability to give you the enthusiasm that I have. Giving rather than taking will give you the advantage against the other. I'm not saying that's foolproof, but as an employer, when I read a CV or I read a letter of intent or a covering letter, when that candidate states what they can give, I mean, obviously it's an equal situation in employment. The employer and employee must be equal. It's not a matter of one being dominant or the other. It's an equality. But I think a lot of candidates, and especially graduates, have this perception, I want this experience and I want this and I want this, I want this. If you remove that and produce an offering that you can provide something rather than taking, I guarantee you will have full success. Because ultimately an employer is looking for someone that will join their team, that will be a part of that team, and obviously provide a service. And in return, you will then get what you're after. But demanding it up front, in my opinion, is not always favorable. It's not one that, so you put yourself in a situation where you want something, you go to someone and ask for that. If they ask, just keep demanding, you're probably going to be more resistant than if you said to neutralize that. And if you said that I can give you this, they're going to be more open for you to do that transaction. So think of it that way, but always come in, not cocky, not arrogant, but come in professional. You're a graduate from Sydney University. You should be very proud of that. You should be adhering to the fact that you are going to one of the best universities. You're a graduate of that university. Look the part, be the part, and do what, as I said, give us an offering. And from there, I think you will always be successful. That's just standing your best chance. That's my advice.
Okay, well, thank you so much for coming in and sharing all of your experience and knowledge and company with us. I'm sure everyone has learned a lot. Thank you so much for everyone on Zoom and in person attending.